PreCalc. We're watching this on Thursday, the 23rd, after our class. And the topic today is log properties. So, turns out there are three rules that we have to understand about logarithms. And I'll start trying to induce, I guess, derive, not really truly derive, but arrive. We're going to arrive at these properties by discussion. So say I have a log to a base b, some base, and I'm taking two quantities and I'm multiplying together. I was wondering if log properties work like this. Would it be the log of u times the log of v? Alright, since we haven't established that with logarithms, we have to arrive at that conclusion or not. So the log of uv, I'm wondering if it's the same as the log of the first times the log of the second. So what's your guess? A little louder. Alright, so I'm going to do it by example. So let's, which is not a rigorous proof, but I think it will help us at least understand, or I believe, what I come up with. Alright, suppose my u is 10 and my v is 10 by example, and my base b is 10. So we'll come back, because that's one we know. So I'm going to apply this perhaps principle. So that would say, I'm saying, is it possible that this expression is the same as taking the log to the base 10 of this times the log to the base 10 of that? Alright, so let's see what we come up with. Well, 10 times 10 is 100. And I'm still wondering if it's the same as the log of base 10 of 10 times the log to the base 10 of 10. And I can come up with this because we are well taught and trained that this logarithm means what is the exponent I give this to get that. What is the exponent for this to get that? So the obvious exponent is 2. 10 to the 2 is 100. But over here, question mark, whether these sides are equal still, what's log to the base 10 of 10? What exponent do I give 10, little 10, to get 10? 1. And then this one the same. Is that a true statement? No, no, no. Alright, so is there a way that I can change, say this operation right here to make this a true statement? Well, I could change this instead of multiply to add. So that means this would be add, this would be add, and this would be add. And sure enough, that's the first law of log properties. Turns out if you have two, in the argument you have two quantities multiplied, it's the same as taking their individual logs and adding them. Alright, let's do a similar discussion with two logs that are divided. So, show you how we're going to use this in a bit. So keep that in a special place in your heart, in your mind. This is your first rule of logarithms. 1 out of 3. Alright, let's see if we can tease the other one out of our brains. So log to the base b of u divided by v. I was wondering if, question mark, it is log to the base b of u divided by log to the base b of v. I was wondering if it works out or shakes out like that. And probably you know what the answer is going to be, but I'll continue to tease you. Log to the base 10, we'll say of 100. Let me write that a little lower, running into my work here. Log to the base 10 of 100 over 10 is that going to be? So this is my U, and this is my V. So I'm going to write this statement. Log to the base 10 of 100. Squeaky. Not sure if the squeak sound of this marker is reaching your ear. I hope not. Alright, I'm wondering if this is true. So let's figure it out. Log to the base 10. 100 divided by 10 is 10. And we'll come back and grab that logarithm. And over here, I'll just repeat that. Alright, so now is our moment of truth to see if this is a principle that holds true, at least in one circumstance. So log to the base 10 of 10 is 1. What exponent do I give 10 to get 10? On the top of this fraction, log to the base 10 of 100 is 2, and on the bottom is 1. Is 1 equal to 2 over 1? No, the question mark has been answered. So, this is not true. So, is there something I can do with this division sign, instead of dividing these two quantities, to make these equal? And the answer is, I could subtract 2 minus 1. So that means I have to go back up here and do log to the base b of u minus log to the base b of v. Then we can erase the question mark, and it holds true. So, it holds true in this circumstance and every other one as well. So, put in words, the log to some base of two quantities that are divided is the same as taking the individual logarithms and subtracting them. So that is super duper cool. The last principle I'm going to give to you and just show you that it works in one circumstance, and you're going to believe me that it works in all circumstances. Alright, so the third rule works like this. Log to the base b of some quantity, we'll call it x, raised to the n. So when the argument is raised to the n, that n can run down in front and no longer be an exponent, it can be a coefficient. So it comes out in front and we get this expression. So notice the n was back here as an exponent, now it's in front as a coefficient, is no longer up here as an exponent. Let's show an example where that's true. So, suppose I start with log to the base 2 of 5 squared. So, I want to know, can that 2 run down in front? And we get an equivalent expression. So we would have 2 log to the base 2. I don't know if I can show it with this. Oh, I know what I know. I'm sorry. Now I know. Alright. Now if you would switch that and switch that. I'll give another run at this. So I'm going to apply this rule to log to the base 2 of 5 squared. And I'm seeing if that will even work. Nope. Alright. Let's try this. One more try. 3 strikes and I'm out of here. Alright, let's go with that. Is that what I had originally? I don't know. Alright, I think I can show it with this one. Log to the base 2 of 2 to the 5th. So I'm wondering if this 5 can run down in front. Okay, this is it. Alright. I'm wondering if these two quantities are equal. According to this rule of logarithms, if indeed it holds, we can. So the 5 runs down in front. Are these equivalent? So let's go and see. So this is saying, what exponent do I give 2? What exponent do I give 2 to get 2 to the 5th? And the answer is 5. Over here I have 5 times the log to the base 2 of 2. What exponent do I give 2 to get to? 1. So I get 5 equals 5 times 1. It worked. So this is my third rule of logarithms. Alright. So get those down and let me show you, I guess, one example using them and then another. So I'll do two examples using them. Alright. I'll try to leave them up. I think I have room to write an example right in here without getting in front of it. So I am going to give you an expression, log to the base 4 of 5 times x cubed y. And the command is to use the laws of exponents to expand. So if something is together, we want to expand it. We're expecting to draw it out, make it longer. So I'm going to use log rules to expand this. And I'm going to expand it till I can't make it any longer. Alright, so first thing I notice here, I have something times something times something. So the rule of logarithms involving multiplication is the first one I came up with. And it says I can rewrite everything by addition, individual logs. So I'm going to expand this by saying log to the base 4 of 5. There's my first factor. Plus, I'm up to here, log to the base 4 of x cubed, and log to the base 4 of, I have room, log to the base 4 of y. Alright, I hope that's on the screen. Now, there's one more log rule I can apply. Do you see it sitting in here anywhere? It's right here. According to this the third rule, that 3 can run down in front. It will run down in front of the term that it's in, not all the way in front. So I have log to the base 4 of 5 plus 3 log to the base 4 of x plus log to the base 4 of y. Alright, so you're saying, why would you like to take something that is nice and concise like this and expand it out like that? And the answer will come one day. Again, this is pre-calculus, so a lot of what we do is sort of unknown to you. But if you go even now to the calculus students and you ask them to take the derivative of this, they will moan and groan and roll on the floor. But if you ask them to take the derivative of this, they will laugh all the way to the bank. And they will give you the derivative lickety-split. Alright, so this is much easier to deal with in your math future, should there be one. Alright, let's look at one other rule. Or let's look at another way we can go. So you'll be asked to expand tomorrow. Alright, so let's look at another kind. This one is already expanded. So we have 1/2 log to the log x. So I didn't write a base, so we understand that it's base 10 log x plus 1. Alright, so this one is already expanded. I can't use log rules to make it any longer than it already is. So I'm going to ask you to go the other way, and that is condense. So we went through expand, and then I'm going to ask you to take this expression and pull it back in and condense it to the smaller expression. So looking at the first term, the 1/2 can go from in front to in backward. It can be an exponent according to this law. It works both ways. So sometimes we want to work this law backwards. We're starting here and going this way. So that 1/2 can run back and be an exponent. That's the second day in a row that 1/2 has shown up as an exponent. And I just hope that you remember from your math past that means the square root. Right, this 3 can run back here. So similarly, we have that. And now we can combine these two logs. So you see they're sitting here, just like this expression. And we're going to go back this way. So we're going to take those two individual logs that are added and turn them into one log where the arguments are multiplied. So I have log x to the 1/2 times x plus 1 cubed. So do you see how I combine these two logs as one log, taking the arguments and multiplying them together? The only thing I would improve on is I would probably on my last step, instead of having x to the 1/2, I would rewrite it as the equivalent square root of x. Alright, so that's how we condense. Condense, we start with this form and come back to this side. Expand, we start with this form and go to this side. Alright, I want you to taste and see that these log rules are good. And we are going to use that goodness, that sweetness in class come Friday. So, till then, we are done.